Hello and welcome back, fellow path integrators, to a very special integral today. Today we're going to calculate the curve integral of a scalar function, which will be f of x, y, z is equal to x squared plus yz. And we're integrating this scalar function along the curve gamma of t being cosine t, sine t, and t. So the vector with the three components. And we also have that gamma is being defined on the interval from 0 to 2 pi, and the whole thing is going to be mapped onto r to the power of 3 because we're having a three-dimensional curve along which we're integrating. So in order to calculate the actual curve integral, line integral, what we have to do is we have to calculate the derivative of our curve. So we have gamma of t, which is here, and we're going to calculate the derivative first. So the derivative, gamma of t, so with a dot on top, will be minus sine of t, because cosine, derivative of cosine is minus sine. Then the derivative of sine will be cosine of t, and the derivative of t with respect to t will just be 1. So this is the derivative of our curve, but now we have to calculate the norm. When we take a look at the integral above here, we see that we need the norm of the derivative of the curve. So the norm of a function, let's call the function f of x, is defined as the square root of the scalar product with itself. So what we're going to have to do now is first calculate the scalar product of this gamma dot t. So we have the scalar product gamma dot is equal to minus sine times minus sine is sine squared, so we have sine squared of t, plus cosine times cosine is cosine squared, so we have cosine squared of t, and then we have 1 times 1, which is 1, so plus 1. And the cool thing here is that this is equal to 1, so in the end we will get 2 for the scalar product. And now all we have to do is take the square root out of it, and that's quite simple. So we get that the square root out of the dot, out of the gamma dot with itself will be the square root of 2, and this is the norm of the derivative of gamma of t. So we're quite far, so what do we have to do now? Let's take a look at the integral again. So what we see here is that our function f of x, y, z is dependent on x, y, z, but we need to make it dependent on the parameter t, so we need to make it dependent on gamma of t. So we see that our x component is cosine, our y component is sine, and our z component is t. So what we can do, if we say that f of gamma of t is equal to f of cosine of t, sine of t, and t. So now for x we plug in cosine of t, for y we plug in sine of t, and for z we plug in t. So our function, our scalar function, is x squared plus yz. So we have f of x, y, z is x squared plus yz. So since x corresponds to cosine of t, then we get that f of gamma of t is cosine squared of t. Y corresponds to sine of t, z or z corresponds to t, so we get here plus t times sine of t. So now our whole integral becomes the integral from 0 to 2 pi of f of gamma of t times the norm of the derivative of our curve dt is equal to, so we have the integral from 0 to 2 pi, then we plug in cosine squared of t plus t times sine of t. Now we plug in the norm of the derivative of our curve, and the norm of the derivative of our curve was the square root of 2, as we can see here. So we just write times square root of 2 times dt. We can extract the square root of 2 out of the integral, so we have square root of 2 times the integral from 0 to 2 pi cosine squared of t. Let's make two integrals out of it, plus the integral from 0 to 2 pi of t times sine of t, I forgot the dt here, dt plus sine of t dt, and close the brackets here. So what we have to do now is we have to calculate those integrals. We know the solution for this one. This is just 1/2 of sine of t cosine of t plus t, and evaluated at the limits 2 pi and 0. We can neglect the constant here. So what we get for this is we plug in 2 pi into sine, and then we get 0. We plug in 0 into the sine, we get 0. So all we are left with is pi as a result, because we have 2 pi over 2, which is pi. So this integral is equal to pi. And now we're left with this integral here. So how are we going to calculate this integral? We're just doing it by applying integration by parts. So let's say from 0 to 2 pi is the integral over t times sine t dt. And let's write down the formula that we know for integrating by parts. So we have the integral from a to b over u, derivative of u times v, is equal to uv minus the integral from ab, I forgot the limits here, so this is evaluated at the limits ab, minus the integral ab of u and the derivative of v. So what we're going to do now is we have to choose which one is the derivative, which one is the normal function. And what we're going to do here is we just say that sine of t will be our uv, our derivative of u, and the t will just be v. So if u, the derivative of u of not x but t, is sine of t, this means that u of t is equal to minus the cosine of t. So we have the integral from 0 to 2 pi of t times sine t dt is equal to minus cosine of t times t. Maybe let's put the t in front so we are not getting confused and the t is not part of the cosine. So minus t times cosine of t, and this evaluated at the limits 2 pi and 0. And then we write minus, and our u will be minus cosine, so this will become a plus. So we have the integral from 0 to 2 pi times over cosine of t, and we need the derivative of v. v is t, so the derivative of t is just 1, so we are left with the integral over cosine of t, which is quite simple to solve. So let's evaluate first this here. So we plug in 2 pi and we plug in 0. So if we plug in 2 pi, then we will get 1 for the cosine, and we will get minus 2 pi for plugging it in into the t. So we have minus 2 pi. And if we plug in the 0, we will get a 0 just for plugging it in into the t. So we are staying with the minus 2 pi. And then we keep on going. We take a look at the integral over the cosine of t. So we just write sine of t because the integral over cosine is sine. And this will be evaluated at the limits 2 pi and 0. So now we know that the sine is 0, both at 0 and at 2 pi. So we're just left with the result minus 2 pi. So let's collect everything together and see what the result is. So what we have is that the integral from 0 to 2 pi over f of gamma of t times the norm of the derivative of our curve is equal to the square root of 2 times pi, so brackets times pi minus 2 pi. And now we can just say pi minus 2 pi is minus pi, so the result is minus the square root of 2 times pi. And this is the result for the curve integral. So I hope you liked this video. I hope you liked spending the time with me. If you really liked it, leave a like, that would be cool. I used a lot of like now, so maybe change the word. If you enjoyed this video, please leave a like, subscribe to my channel, and yeah, do anything that you think might help with the algorithm, because recently, I don't know, my videos are not being watched anymore. Maybe you don't like them anymore, just let me know in the comments what I could improve. Yeah, that's all. So, wish you a happy week, and goodbye. See you soon in the next video, my fellow path integrators. Bye!